Magandang umaga everyone. Magandang hapon everyone. Today's lesson is about absolute value equation and inequalities. Our goal is for you to start doing your warm-up. So I want you to get your green paper, and then afterwards you're gonna play along this video so you can follow. So for today's bridge, says solve each equations or inequality and then check your answers after. I'll record a separate video for doing everything in Desmos because I can't switch my screen and record at the same time. So I am trying to just focus on making this in writing. So for number 1, what will I show you is how to do this manually, and then later I'll show you and I'll record again doing this through Desmos. So given that negative 3x equals 12, so you're gonna divide this by negative 3, both sides. Cancel, and then x will be equal to negative 4. Now, it says here that we need to check our answer. Check our answer meaning you're going to plug that back in. Later, I'll show the answer. Checking if our answer is correct. If the x value is correct. So here, you're going to add 7. And then cancel this out. 2x equals 21. So since we can't divide 21 by 2, just leave it like that, 21 over 2, or just divide 21 by 2, which is 10.5. Okay, let's see if that is correct. Okay, again, I'll plug in later all those values of x so we can see if they are both equal. For this first warm-up, this is an absolute value, meaning it can be separated by absolute value of x equals 9 and absolute value of x equals negative 9. So therefore x is equal to 9 and x is equal to negative 9. Same thing with the other one. You're going to separate the two. You have, well, I have a PowerPoint for that. X plus 2, or absolute value, x plus 2 equals 9, and absolute value of x plus 2 equals negative 9. So with the equation, x plus 2 equals 9, you're going to subtract 2 in both sides. I'll show you later the better work for this. X is equal to 7, and then the other one would be x plus 2 equals negative 9, subtract 2, so therefore x is equal to negative 11. Alright, again, remember the answer, negative 4, 21.5. This is not 21.5, sorry. This is 21 over 2, or 10.5, and then this is 9 and negative 9, and the other one is 7 and negative 11. I'll erase everything because again, I'll show you the checking. How will I remove that? Erase. Okay, erase all. Alright. So again, first answer is negative 4. So if you're going to plug that in, negative 3 times negative 4 equals 12. So 12 is equal to 12, meaning negative 4 is correct. Number 2, 21 over 2. If you're going to plug in 21 over 2 in terms of x, 2 times 10.5, which is 21 divided by 2, minus 7 is equal to 14. So that would become 21 minus 7 is equal to 14. And then 14 is equal to 14. So correct. This is correct. Next, 9 and negative 9. Correct. So here, this is what we did earlier. That's correct. Okay. If you want to plug in, oh, I didn't do plugging in here. So if I plug in 7 here, is 7 plus 2 equals 9? Correct, right? Okay, so it's correct. The other one is negative 11 plus 2 equals 9. So negative 11 plus 2 is equal to negative what? Negative 9 equals, this is 9, sorry. Okay, equals 9. So absolute value of negative 9 is positive, so 9 equals 9. Got it? Alright. Okay, let's proceed to examples. Okay. So, two equations from 1. This is activity 1, page 74. Andre likes thinking of absolute value functions as piecewise functions like he did in activity 2 of the previous lesson. He thinks that to solve the equation from the warm-up, absolute value of x plus 2 equals 9 algebraically, he could use two equations. Andre's thinking are x plus 2 equals 9 and the other one is negative x plus 2 equals 9. If you remember what I did in your warm-up, I said absolute value of x plus 2 equals 9 and absolute value of x plus 2 equals negative 9. But Andre's thinking is different. The negative is in front and the other one doesn't have anything. But still, Andre got the same answer, 7 and negative 11. So, did Andre get the correct answers? Of course. Do you think Andre's method will work for all absolute value equations? I would say yes, because Andre's answers are correct. I think it will work for all absolute values equation because absolute value of A equals B and always means either A is equal to B or negative A is equal to B. Let's keep going. Next, let me erase this one first. Okay. Next number. Use Andre's method to solve the following equation. Substitute your answer back into the original equation to verify your correct answer. If you want to use Andre's method, that's okay. However, I would recommend you the proper way of doing it. The pattern will be the way I did it in your warm-up. Okay, so if you want to do that way, this should be the answer. X is equal to 6 and x is equal to negative 5. B, x is equal to 14 and x is equal to 10. C, x is equal to 7 over 3 and x equals negative 17 over 3. And the other one is no solutions. Now, the reason why I did not show work here is because I want you to apply what Andre's method earlier. And then compare if you will get these answers. Okay, if it does, meaning it is proven and tested that Andre's method is correct. Alright? Let's do another example. Now, are you ready for more? Use Desmos to graph equations y equals 2x minus 1. On the next line, graph the linear equations y equals 11. What is the solutions to this system of equations? Again, I cannot switch my screen and record the other screen. Later, I will show you how to do this in Desmos. So, meanwhile, I'll skip page 75 and I will let you go back there once I am recording the Desmos activity. Got that? Okay. But if you want, you may try doing it manually. But again, the answers are x equals 6, x equals negative 5, x is equal to 1/2, no solution, and a system with two solutions looks like a line crossing a V twice. A system with one solution looks like a line intersecting the vertex of the V. And the system with no solutions is a V and a line that do not intersect. A graph approach. Okay. So it says here, use the graph of systems y equals x, absolute value of x plus 2 to solve each. And then the other one is y equals 5 of the following. Now A, B, C. Okay, so this is your graph for the absolute value of x plus 2. And this is your graph for y equals 5. So here, there is an intersection. If there is an intersection, meaning those are what you call solutions. Since there are two equations involved, this is the first one and this is the second one, what you're really looking for are their intersections. Now, it says x plus 2 equals 5. 3, let's see. Absolute value of 2 equals 5. So 3 and negative 7. Negative 5, oh, negative 6, negative 7 here. That is correct. Look at that. Okay, look at that. That's equal. The second one will be negative 7 and negative 3. Again, I'll show you the graph on how you're going to plug this in, and I'll give you a precise answer why it becomes negative 7 and positive 3. Next, x plus 2 less than greater than 5. So, all values of x should be less than negative 7, or the value of x are greater than 3. And then explain how the solutions to the equation is related solutions to the inequalities. Okay, activity 4. Access Desmos to solve the absolute values inequalities by graphing. So here, since this is inequalities, yes, graphing is the only key to answer this one, and you will understand why. So, but then for now, I'll give you the answer of 1 and 7. For letter B, oh, here, I provide the graph. So if you're going to plug this in, the whole equation, this is how the graph look like, which means that the values of x would be 1, not less than 1, but equal to 1, 2, 7, but not more than 7. So the solutions will be only staying inside, the one that is shaded. These are the solutions, okay? Now, letter B, no solution. Look what happened. If you graph this one, no shaded portion will show up, meaning there's no way that you can find any answer for this one. No solutions. Letter C is x is less than 2.276 or x is greater than 3.67. Why? Because this is how the graph look like. You see that there is an interval, so meaning they are separated. All values of x lesser than that, and all values of x greater than that. Okay, so these are the solutions. Solutions, and then solutions. So, but not this one. Not the middle one. Alright? Practice problem. Let's go practice problem. Page 82. A carpenter is building a table for a family. The carpenter is working on the final leg of the table. In order for the leg to fit, it needs to be 175 millimeters wide, allowing for a margin of error of 2.5 millimeters. Write an absolute value inequality that models this relationship and find the range of width the table leg can be. Now, this is a margin of error, which means that it is an absolute value of x, and whatever is the bigger number will stay inside, and then it is always less than or equal to, and then whichever is the smaller number will stay outside. Now, if you're gonna plug this in, this will be your answer. Now, either way, the fourth leg of the table can be, the reason why it says margin of error, it can be 172.5 or 177.5, which means that up to this range, it can still be acceptable as a leg measurement of the table. Next, for letter A, you're gonna solve that, and I'll show you later how to do that in Desmos. But if you want to do it manually, it's the same thing that I show you during the warm-up. Okay, but again, the answer will be x equals -1 or x equals -5. Next, letter B. Absolute value of 7x plus 4 over 8 and equals 3. So there are two answers. X is equal to 20 over 7, and the other one is x equals -4. Next, number 3 is no solution. I'll show you that in Desmos later in my second recorded video. Practice problem number 3. I can't do anything here since this is inequality. What I can share is later the video of doing this set in your Desmos. Okay, but I'll show you the answer. Here are the answer. Just for your verification. There you go. Problem number 9. -6 is x. It is x. Now, if I'm gonna find -6, that would be -5, 6, 7, 8, 9, 10. So here, -6. What is the y value of -6? 0. Okay? Oh, never mind. It says -2. Why negative? Oh, sorry. So that would be -6. Yep, this is -2. Correct. Yeah, that's my fault. Now, h is 0. Where is 0? So what is the y value? The y value will be 6 because it's in here. Correct. Next, h of 2. Where's 2? 1, 2. Here's 2. And then the y will be what? 6. Next, 7. Where is 7? 6, 7 here. So what is the y value of that? So you're going to put it here. If this is 6, that is 7. So I say 7. Next, h of 0 is 6, right? So that is 6. And then 10, if I'm gonna go look at 10, 5, 6, 7, 8, 9, 10 here. That is 10, so that would be, what is this? 5, 6, 7, 5, 6, 7, 8, 9, 10. So 10 as well. So this is 10. So multiply by 2 because it's outside number. And then you're gonna add. So this is 20, so the answer is 26. That is correct. Alright? Next, cool down. Now, answer this in a separate paper. And then, I want you to do this as your classwork today. Yep. It's either you're gonna click this PowerPoint or enter to join quizzes.com. Again, this will be recorded. So the next video that I will be recording is doing all this in Desmos. Goodbye.